In chapter 5, we had a vertex. And what's going to be new, one of the new features of this chapter is we're going to talk about something called a focus. And when we start talking about a focus, you really see the applications of parabolas and the way they affect you. All right? If you think about a satellite dish, and maybe some of you have those at your house, the way those work is the signals come in from space, they bounce off the dish, and because of the angle of the dish, they all bounce and go to the receiver. So all those signals from the whole dish, they all hit and they all go to the same place. So you get a concentrated signal at the focus, which is inside the parabola. Okay?
And that works.
If you've used a magnifying glass, that's the same thing that he would have been doing. If you've used a magnifying glass to set fire to a leaf or something like that, it's gathering all the sun's rays from the entire expanse of the parabola, and it's all garnering it on the focus of the parabola of the magnifying glass. So you get a super hot point, which is what Mr. Glass was trying to find with the hot dog. He was trying to focus it on the super hot point. Okay, the line under the parabola, there's a line, it's called the directrix. It's horizontal. We're only doing vertical parabolas in this section. There are horizontal ones. We're not going to cover them because it's the same material, it's just sideways. It doubles the work for no real reward. It's a line that goes under the parabola. It is equidistant from the vertex as the focus. So you see this red line here? That's the same distance. And what's interesting about it is if you drew another line from the focus to the parabola and from the parabola to the directrix, that line's the same distance. And no matter where you drew the line, you would have the same distance. We have the axis of symmetry, which is a vertical line, a pole that runs straight up and down through the vertex. We talked about that last semester. And then the last piece is a measuring stick, really, for the parabola. It's called the latus rectum. It is a segment that runs, it's this blue line down here, through the parabola, stopping here and here, through the focus. And that length is basically a measuring stick to tell you how fat or skinny the parabola is. Okay? So those are the pieces of the parabola that you're going to have to find, or whatever, as we go through these problems. On your cat for to make a pair of kitten britches, you will see these formulas. The only one that's not on there that you have to remember and know is the one that I've circled, the direction of opening. A is positive, the parabola goes up. A is negative, the parabola goes down. I did not write that one on the formula sheet because I think you can remember it. Everything else up there is provided on the CATFR. Okay? So you don't necessarily need to write them down, but you certainly can if you want to. So what we're going to do now is we're going to take an example, and we're going to go through the finding of all the pieces of the parabola, and we're going to graph it. Graphing is an old skill for a parabola. It's from chapter 5, but I'll talk you through it once. And then we're going to move to a more complicated problem that's not all set up. This one's kind of set up for us because it's in vertex form. Okay? So first I'm going to show you how to graph it, the very simple process that we learned in chapter 5. Okay? The vertex, this is in vertex form, is -1, -3. If you remember from chapter 5, we had to take the opposite of h, because it's x minus h, Remember that? Since it's x minus h, it's -1, -3. So our vertex for this parabola is right there. And the way we graphed these last semester was we did the 1, 3, 5, 7 trick. In this case, we're going to take the 1, 3, 5, 7 and we're going to multiply it by 2. So our 1, 3, 5, 7 is going to be multiplied by A, which is 2. So from our vertex, we're really going to go 2, 6, 10, 14. Okay? So from our red vertex point, we're going to go up 2, and then up 6, and then my 10 won't fit. And so then I just draw a line, and there's my parabola. So the pieces, moving to a new slide, we already found the vertex, formula HK, value -1, -3. What I do when I'm doing a problem like this is the first thing is I'm going to find out what H is, find out what K is, find out what A is, and I'm going to write what those values are. That way, instead of going back to the equation over and over, I'm just going to look at my values. Because if I keep going back to that equation, one of these times, I'm going to say H is 1. If you look at that equation. Because it says x plus 1. And I'm not perfect. One of these times I'm going to look at that and I'm going to say 1. So what I'm going to do is I'm going to look at the equation one time and I'm going to say H is -1, K is -3, and A is 2. And then I'm not going to look at the equation anymore. I'm not going to run the risk of making that mistake. Okay, so now, focus. Formula, according to the cat, to make a pair of kitten britches, H, comma, K plus 1 over 4A. So all you have to do is take that and substitute in H, K, and A values. Which, if I do that correctly, I believe is -1, comma, -3 plus 1 over 8. The 4 and the A are both on the bottom. I'm just plugging in the values. And then I can actually do -3 plus 1/8 to get -3 and 1/8. Directrix. Formula. Y equals K minus 1 over 4A. Which, if you think about it, is almost identical to the y coordinate of the focus, only it's minus in the middle instead of plus. So I've done enough practice problems to know that I don't even have to do this. I just have to take the y coordinate of the focus and switch the sign in the middle. -3 minus 1/8, which is -3 and 1/8. Like so. I'm just taking the formulas from your cat to make a pair of kitten britches, plugging in the values H, K, and A, and figuring out the answer. Ma'am. Next piece, axis of symmetry. X equals H is the formula. So the answer would be X equals -1. Yeah. Next piece, direction of opening. Since the A is positive, it's going up. I'll tell you what pieces define when I ask a question. I'm not going to say find the pieces and let you figure out what the pieces are. I'll be more descriptive. Just in this question, I just said find all the pieces. And then, what do we have left here? Length of the latus rectum is a distance. That's why it's absolute value, because it's the distance from parabola to parabola through the focus. It's the absolute value of 1 over a, which is the absolute value of 1 over 2, which is 1/2.